What's up, everyone? I want to thank everyone that decided to subscribe into the channel when I uploaded my last video. My guide to PVM or load cycling and D.I.G.E has received minor updates in the comment section, so anyone who is interested is invited to revisit the last video and check the comment section for updates. There are also written guides for this video and my last video available on SKPort, so when you're using SKPort, feel free to visit those guides and bookmark them and keep an eye on the account so that you are aware of future updates. Today I want to demonstrate a different idea for power delivery in your base. So while we are talking about stuff like D.I.G.E stuff, independently other people also work on their own solutions for power delivery, and this solution here is interesting in its own way. It has its own advantages to the things I've shown before, and it has its own disadvantages to things I've shown before. So this is an adaptive power generator. So what does it even mean that it is an adaptive power generator? So being an adaptive power generator means this generator produces anywhere between 2000 to 4000 watts. With the 200 the pack gives us, this means it produces anywhere between 2200 to 4200 in total. And what makes this design interesting is that it starts at 2000 watts, so 2200 in total. And once you start exceeding 2200 needs, well, I'm producing a little bit more right now because I still got my other factories going, but when you exceed the power delivery that these design provides by default, which is 2200, the design automatically adjusts into a higher step of 100 watts. So if I were to consume 2250 watts, the machine is automatically going to adjust into producing 2300. If I consume 2350 watts, it automatically adjusts into 2400 watts, and so on. So how the hell does that work? So the things that you need to know is that there's a blueprint in the description, but there's very specific setup steps. The first thing you want to ensure is you want to insert batteries input-output. By default, the conveyor belts are laid out in a way that you can immediately connect them to a puck, but this may be a little bit too inconvenient for you. So you can just adjust the conveyor belts. I did just something really messy here with the depot unloader and loader, but it works. So just ensure that there's a way for batteries to enter and a way for batteries to exit. That's the first step. The second thing you want to ensure is that all the protocol stashes are turned off and set into storage mode. They shouldn't be powered by default anyways, but this is just to ensure that if you accidentally place a pylon nearby that you not break your entire power delivery. There is no way to save that with blueprints, so you have to do that manually for the 4 protocol stashes. Then the next thing you have to do is you have to insert 5 stacks of any junk item into this protocol stash here. The original designer of the blueprint opted for sandleaf powder, but the idea is basically the same for if you guys ever did like redstone in Minecraft or something. You may recognize designs that need cobblestone to be filled into hoppers or chests to pollute slots, and it's the same idea here. Like this sandleaf powder has no actual purpose other than ensuring that this 5 slots are occupied and cannot be used by anything else, so that we only have 1 slot to work with. This 1 slot we want to then occupy with exactly 11 therium that is inserted into this protocol stash. If you insert too much, this item control port should ensure that you're not messing your factory up, but like technically you only need 11 therium, which you can get by like processing therium or in a refining unit. I just stole mine from my steel ball production or therium ball production. The next thing you want is 21 originium crust. There's also a control port to ensure that you're not inserting too much in here, which you can, I don't know, just get from refining originium, or I stole mine from my silverite component production because I've hit weekly cap anyways. And what this will actually do is have all the therium loop in here and all the origo crust loop in here. It can take a minute or two until the machine is ready to operate, And the thing that you're looking for is that all the Origo crusts at the bottom portion are spaced out the way they are here right now. Basically, that is one Origo crust surviving every 4 seconds. So when we see one here, 3, 4, boom, there's the next one. You want to have 4 second spacing. The machine does that automatically. It can just take a little bit until it's synchronized. This is the setup process. Once you see it that way, the machine works. Now let's talk about how it works. So we got these batteries going in here, and the idea is similar to the 12-bit PWM that I explained in my previous video. We think of this battery as in the total power delivery it provides, which is 32,000. So as it goes through the splitters, that's gonna cut in half, half, and half. So 16,000, 8,000, 4,000. By the time it reaches the thermal banks, the batteries will, on average, over an infinite amount of time, produce 4,000 watts. So far, so good. We have just explained the higher boundary of the design. The 4,000 in the 4,200 watts max that this can produce, or the factory it is laid out for. How do we get to 2,000 now? And the answer lays in this Origo crust cycle. So we have Origo crust cycling in here that we can shred into Origo crust powder and then turn back into Origo crust. So this is an infinite loop that always operates, because we can turn it into powder and turn it back into crust, which we can then turn back into powder and then back into crust. And we use that in order to pollute this converger here. So basically we have this shredding unit here spit out Origo crust powder every 2 seconds, similar to how there's batteries arriving every 2 seconds. And because neither of the shredding unit or the item control port has a higher priority, the converger operates in round robin and is gonna alternate between the batteries and the Origo crust. So the Origo crust obviously gets filtered out here by this control port, while the batteries get filtered out here. But basically that means is, while this loop is operating, the flow of the batteries is cut in half. So this is why there's only 2,000 watts arriving instead of 4,000 watts. So I've just explained how our battery flow turned from 4,000 watts into 2,000 watts, but it doesn't explain how it automatically scales up. And the magic happens in the Ferium loop. So we have this protocol stash here, and the way how this Ferium loop is built is that there's always at least one Ferium in that last remaining slot. The refining unit tries to push an Origo crust in there, but can't because, well, the slot is full. So the only other option it has is to push the Origo crust back into the loop. Now, what happens if the Ferium production doesn't work anymore? So, following example, I'm producing too much electricity. What's gonna happen? The factory is gonna crash. When the factory is gonna crash, the shredding unit, refining unit, this refining unit, this shredding unit do no longer work. What that has as a consequence is, well, the refining unit can no longer spit out Origo crust, the shredding unit can no longer block the battery flow, and all the Ferium is gonna pile up on the shredding unit because it can no longer be shredded and refined. Eventually, there's no Ferium inside in here anymore. The one Origo crust that is trapped in here is allowed to enter the protocol stash. From there it gets led into the protocol stash 2 and gets trapped in here because the item control port is already hitting the max quantity. So basically each time the factory crashes, one Origo crust gets removed out of the Origo crust loop, which means that there's less interruptions in the shredding units interrupting the item control port with the batteries here. That means more batteries get passed through, and this averages out on about 100 watts more for each Origo crust that is removed. And that way the machine is automatically adjusting. So the best way how to test this, honestly, would be if I basically butcher my entire power production. So what I'm gonna do is I'm gonna turn this off, I'm gonna turn this off, and I'm gonna turn this off, and suddenly I'm not really producing enough power anymore, right? It's gonna be fine because eventually batteries are gonna balance out into the second thermal bank. So if I really want to crash this, I have to produce more, I have to use more power, right? So let me think of a way of being very wasteful with powers. How about some seeding units, huh? That seems like a great idea to waste power. Just place some seeding units down here. 217, we can do better than that. 221, that seems good. So now I'm using 5 more watts than what this can design. This would still take a while to crash that way, but I'm just gonna, I don't know, keep adding new seeding machines. There's probably a better way to do that. I know, for example, the Forge of the Sky has like higher power usage, but the thing is, like, the Forge of the Sky, I can't place down infinite of these, so I'm gonna have to help myself, and I just saw that I had like a shit ton of seeding units laying around, so let's just use that, I guess. So, do I have enough to replicate this? Yo! 2.3k. Oh my god, I think that was a little bit too much. Yeah, that was a little bit too much. Let's 2.29, perfect. So, yeah, this can produce 2000. We get 200 from the pack. Now we kind of have the problem that this factory is gonna crash. And I'm gonna let this crash now. And once that crash happens, we're gonna see that the Origo crust here gets removed, and that there's gonna be more gaps in here. So, after what felt like 15 minutes, we have finally crashed in our factory, but it's gonna cause all the production machines to turn off. There's not gonna be enough therium anymore eventually, and the Origo crust can pass through and enters the protocol space too. That means there's one less Origo crust inside this loop now. And while the shredding unit is blocked, it can no longer produce powder, which means that more batteries come through. So the machine is gonna temporarily turn on watts close to 4000 watts of power delivery, up to 4000 watts of power delivery on average. Turn everything back on. There's another Origo crust getting trapped in here because the therium is back, and we have successfully taken out... Wait, is that free? So yeah, that can sometimes also happen, it seems. That's the first time for me that instead of one Origo crust, 3 Origo crust got trapped in here. But as you can see now, there's now more bigger gaps inside this power delivery, and the power supply is automatically delivering more power now, because as there's less Origo crust in this loop, there's less batteries being blocked by the Origo crust powder production here, and more reach the power supply. So if we wait long enough, we will see that while nothing changed my power demand, I'm now capable of producing the power that previously caused the factory to crash. Because now more batteries come through. In fact, because 3 Origo crust got removed, my power output should have increased from 2200 watts to 2500 watts. And this should cause this factory to no longer crash. Guess for another time, speed up. I think I have given enough time now to show that the power of our internal battery increases as we are now producing more power than before, and in fact creating an excess. Now, optimally, there should only be one Origo crust entering this protocol stash during a power outage, but now that 3 have entered, instead of producing 2300 power, we are producing 2,500. Yeah, 2,500. But it's also a good opportunity to show how to deal with like adjusting the factory in case you're scaling down again. So as I've demonstrated, this machine is capable of automatically increasing its power output when you scale your power up. However, this doesn't work when you scale your power down. The machine cannot do that. If you want to reduce the power output again, what you have to do is to bring your Ouigo cost back into the machine, which is basically what I'm gonna do here now. You can use the control port for that. I'm gonna set the control port to 2 now. Oops, I just set it to 22, that's why 1 came through, so I'm gonna set it to 1 instead. Let 1 through. And that causes 2 to leave now, and 1 Ouigo cost stays inside, and now I have reduced the power output of the machine again to 2,300, and that should also be sufficient to 1. So that's basically the demonstration of this machine. Now let's talk about the advantages and disadvantages. So first of all, the advantage is this design is a lot more stable to previous blueprints we have seen. When we look at like the OG 12-bit PVM, this one was would crash in certain numbers, and the numbers were not really clearly visible for the user because they are caused by superpositions in the binary decoder. Like 1899 watts would simply crash on this machine. The other blueprint is much more stable and will not easily crash because, as you see, there's a relatively predictable cycle. You can maybe catch that in the video when slowing down again or something. Now, that's it with the advantages for this design. And I mean, of course, one advantage, the big one advantage is this design adjusts itself, so you can basically place it down, and when you keep building new things in your factory, it's gonna adjust itself, and you do not have to bother about it too much. So what are the disadvantages? Now, the thing is that this machine operates in a much smaller range than the old 12-bit PVM blueprint. The old 12-bit PVM blueprint can operate anywhere between 800s, can produce anywhere between 800 to 4,100 watts roughly. This here is only 2,000 to 4,000, so you have much less options than before. You have seen it myself. My factory that is like absolutely stacked out with like maximum selenite production, maximum battery production, syringe production, Jinkao. I'm like doing a lot of crazy shit, and I'm even having like a zipline network to all the important locations in Wuling, like rare gathering spots, depot stations, recycling stations. To get the idea, like I have not been I haven't been greedy on placing down things, and I'm not taking up enough power for this blueprint to work without me like wasting power on placing down junk. So I'm not sure who of you guys needs more than 2,200 watts of energy, but if you do, that blueprint is for you. My factory is just too efficient for it to really make sense, and if you were to be too inefficient, like over 4,200 watts, which in a future update that can happen, this design will also no longer work for you. So like, you have to be in this very specific range, 2,200 to 4,200 watts of power demand across the entire factory, to 200 of the pack included, for this blueprint to come and crash for you. So what's the next issue? Now this blueprint shares a very similar issue to the previous 12-bit PVM blueprint. Its design philosophy is balanced around the LC Wuling battery. You've seen that at the beginning when I took the LC Wuling batteries, total 32,000 watts of power delivery and divided through it. This would obviously not work the same way with AC Valley batteries or any other battery. If we were to insert AC Valley battery here, let's actually do the math. We would have a total power of 22,000 coming in here, divided into 11,000, 5,500, 2,500 something? Yeah, so the higher boundary of this entire machine would be somewhere around 2500 watts, maybe 2700 watts. I would have to do the exact math, but the idea is like you would get anywhere between 2000 plus minus 2700 watts at most when using this with AC Valley batteries, which I guess can work in case you are like muling AC Valley batteries from Valley to Wuling and power your Wuling factory with that, but this design is just not gonna cut it for Valley 4's power demands. It would be even less once we realize that like we have to take this 2700 and cut it in half because of this splitter here, making it like 1300 by default, so it ranges anywhere between 1300 to 2700 roughly watts. That's just not enough for Valley. And this design here would not exactly split into 100 watt steps either. It would be like, yeah, basically you take like 1300 divided by 20 and then you know in what steps this operates for AC Valley batteries. So yeah, this design is not gonna work for Valley, and there's also no easy way to fix it, unlike the 12-bit PWM design that I've previously demonstrated. So this design is pretty much exclusive to Wuling as of now. Another thing to keep in mind is, because of how this machine operates, you're gonna waste anywhere between 0 to 100 watts. If your power demands exactly matches a multiple of 100, that's great. If you are like needing 2205 watts and you have to produce 2300, you are wasting 95 watts. And we have much better solutions for that. Now, one thing I forgot to mention my written guide, but now that I look at it and became kind of clear with like me having rotate and everything, this thing is a little bit bulky. Like when you compare this to D.I.G.E, you could fit 2 phases of D.I.G.E and they are still save space. So like this thing is pretty big. And in that regards also much more limited than D.I.G.E. But obviously it has the advantage, it has a blueprint. So when you guys would ask me, what am I gonna end up using? I'm gonna be real with you guys. I'm gonna be sticking with D.I.G.E. But if you're really this type of person, or you know someone in your friend group that goes like, I not wanna learn about electronics, I not wanna learn about PWM, I just want a blueprint that does the stuff for me, and he happens to be anywhere between 2200 to 4200 watts of power delivery, this is a pretty good alternative. Needless to say, this design works because of how the LC Wuling battery works and what our power demands are in endgame right now. So whenever we get like new batteries or like new upgrade to Wuling that's gonna require like more power, similar to how Valley takes like 4000, 5000 watts now, this is not gonna work. So this is a temporary solution for people that just want to copy and paste something into their factory and forget about it. But for anyone that wants something more future-proof or wants to optimize this more, I would suggest using D.I.G.E instead. And there happens to be a video about D.I.G.E on my YouTube channel. So if this adaptive power generator happens to be my introduction to my YouTube channel, feel free to also check out my previous content. There may be something for you there that is closer to your needs, but at the end this is really just up to your personal preferences. For me, this is not something I'm gonna use, but I can tell from the feedback on my written guide on SKPort there are people that just want blueprints and forget. So I guess if you're this type of person, here it is, have fun. I'm not gonna stop you. Yeah, if you guys have any questions, then just leave them in the comments. I will try to look over all the comments and answer them. And if you guys have any designs or anything I want to showcase, then also post them into the comments so that I can take a look at them.